So without further ado, I'd like to turn it over to Dr. Robonham to speak about today's controlling LEDs to meet customer expectations.
Great,
Take it away.
thank you, Jeff, and then thanks everyone for being on the call. I'm just going to start sharing my screen so that you guys can see what I'm talking about.
And that's not really your office that you're in, is it?
Yeah, maybe. No. This is the first time I've used this medium, and I found that you can change the backgrounds like all the rest. So this is my fake background. So you should be able to see controlling LEDs to meet customers' expectations. Is that correct?
Yes, we're good to go.
Okay, perfect. Well, like I said, hello everybody. My name's Ian Rowbottom. I'm a principal engineer at Lutron. I started my 33rd year this week. This was my anniversary at Lutron, and I am really excited to present this CEU to you today. It is registered with the AIA and the CES for continuing professional education. So there's not any manufacturer content in here. I'm going to be giving you a basically talking about the theory of LED lighting and giving you good practices. This will give you one CEU, and this is the company. At the end of the presentation, we're going to save time for questions. So if you have any specific questions about product and things like that, I cannot answer them during the presentation, but I will cover them at the end if you need anything. So today we're going to talk about the features and benefits of LEDs. We're all using them. It's the ubiquitous light source of today. And I want to really have people think, well, why am I using them and what can they do for me? I'm going to talk about the components of an LED system and what types are available, because some are appropriate for certain lighting and some are not. And I really want you guys to have an understanding of where you use them. Want to talk about dimming and color quality of LED because they are not all the same, and you can do some things for your design to make it better or actually make it worse. And we're going to cover those. And then I'm going to talk about how you specify a compatible LED and dimmer system to make a beautiful well, I just saw a thing to annotate the shared content. I don't know. I'm just going to approve. Oops. Now it won't allow me to move screens.
Oh, I think it went into annotate mode where it wants you to draw on the slide. So I think you have to just get out of that feature.
Yep. Okay. Thank you. There we go. Okay. So let's start with the first slide. You guys all have a home, and in your home you have a kitchen, a dining area, a living area. So have a look at this picture that's on the screen. What are the key things that we need to specify in order to achieve the aesthetic that you see? What did the lighting designer decide on? Well, a couple of things. Fixture type, they're not all the same. I have some, let me just pull up a laser. I have some can lights up here. Looks like I have a track head here. In these table lamps, I probably have screw-in LED and maybe independent lamps. So I've got to look for different fixture types with Edison-based bulbs, with maybe plug-in bulbs for the track heads, and then behind the soffit here, I might have some LED strip lighting. The other thing that I need to consider is what is the color temperature of the LEDs for this application? Typically residentially we do 2,700 Kelvin to 5,000 Kelvin, whereas commercially we're more in a 3,000 to 6,000 Kelvin, a much cooler white, a much bluish, more blue white than in the residential that wants the red tones. There's something here that says 95 plus color rendering and a R9 value that's high, and we'll cover all those during the presentations because I see some artwork. I see a dining area with a fruit bowl and a food prep area, and I don't want to pull my I don't want to be slicing my orange up and it looks purple. I want it to look like an orange, and something called color rendering can affect how that orange appears. Do we want to dim all of these light source? What is the dimmability, the range, and the performance? And then once we've chose the fixtures, what kind of dimmer do we need to make all this work, or dimmers? So these are some of the things that we have to consider when we are putting an LED installation in. So, how often do you specify LED and why do you specify them? Well, we all have our reasons, but these are the most common reasons. High efficacy, and what that means is for every watt that I put into a light source, how much light or lumens does it give out? Just as a comparison point, the old incandescent light bulb that we had for over 120 years had an efficacy of about 12 lumens per watt. So for every watt I put into that old light bulb, I would get 12 lumens of light. Well, now LED is about approximately 150 lumens per watt. So we are more than 10 times more efficient producing light with LED than the old incandescents. So a 20 watt LED can easily replace a 100 watt incandescent. The other advantage of LED is reduced maintenance costs. The old light sources lasted, say, 1,000 hours, or if you're, say, still using the MR16 little whatever it is, I don't know, 1.5, 2-inch lamp with the halogen capsule in there, they last about 2,500 hours. After 2,500 hours, they're typically up on high ceilings and it's really difficult to replace. Well, now LED is replacing all that, and we can have 50 plus thousand hours of lifetime. And unlike the old incandescents, which their lifetime was rated, or even fluorescents, say I had a lamp that was rated for 1,000 hours, what that meant is if I had a sample of the lamps, 50% would be dead, completely non-functional at 1,000 hours. With LED, they just reduce their light output at the rated light. And we'll see that on a spec sheet, and I can explain that. We can have color temperatures anywhere from 1,400 Kelvin to 5,000 and beyond. So I can match the color temperature of the LED to the application that I'm trying to do. And then, the color rendering, again, we're going to touch on this in a little while, but 90% or 90 CRI is available and higher is available. So we can get very good representation of true colors. So some of the challenges, though, think of projects that you've done with LED. Have you ever had them flicker? Have you ever had the color not seem right? Not actually, I want to do a dimming application. Did it really dim? So there are some challenges, and we can bucket them into a few buckets. System compatibility. I chose a certain fixture, but the control that I tried to use wasn't really compatible or didn't give a good dimming range. Um, I had a ceiling full of can lights, and I noticed that there was variation between the can lights. What's going on? Why don't they all look the same color? And then, I was happy with the installation, but over time, I think the installation is looking a little bit green. What's going on? Well, LEDs can change color over time, and we'll discuss that. So basically, at the top, what you can see is there's something called the color space, and that's all the colors that human eye can see. Within that color space is a line, and that line is called the black body curve. That is shades of white. So, when we are looking for a light source, we may say, oh, I want a 3000 Kelvin light source. That is a shade of white, and that would correspond to a certain point on the black body curve. Well, on the black body curve at, say, 3000 Kelvin, which would be a incandescent running at full, or a warm LED, you often see a line drawn on the black body curve. And what that represents is it can represent color that is not part of white, but it's what the LED can give out. So say I bought a fixture, and instead of my fixture exactly being on the black body curve, which would be an incandescent or the sun, but my fixture is up over here where the dot is on the screen. What you can see is I've moved away from the shades of white, and I am moving towards a green shade. So even though my fixture still gives off 3000 Kelvin, it would look slightly green. And unfortunately, over time, those LEDs, the phosphor ages, and they can start to move up and down this line. If by chance my fixture started off right in the middle, a beautiful shade of white, but over the life of the lamp, it moved in this direction, you would now the fixture would look like a shade of pink. So you can see that LEDs will change color over time, or they can shift, left to right and do different shades of white. So here's how this plays out. Here's a specification. This manufacturer said that their fixture has a two-step macadam ellipse color consistency. I'm going to go back one slide. So each of these circles drawn around a certain color temperature on the black body curve is a macadam ellipse. If I put my dot over the 3000 Kelvin one, you can see the dot completely covers the first circle. A single macadam ellipse, there is not a person on earth that could tell the difference between fixtures that are within that one macadam ellipse. As I start to go to two macadam ellipses, there are lighting designers and very astute people who notice color very easily may see a slight difference. If I then move up, so that would be the second circle that you can see. If I then move up to the third circle, pretty much everybody in the population would see a difference. And then the fourth is worse and the fifth is worse. So the fixture that is specified here has a two-step macadam ellipse color consistency. What that means is that fixture, to the casual observer, if I had multiple fixtures, they would look the same color. If I was a lighting designer and I really intensely looked at them, I may be able to see a slight difference. The other thing that you note on the specification sheet is the warranty. Well, they give a 10-year fixture and dimming warranty and a 5-year LED color shift warranty. This is a pretty fantastic warranty on this fixture. And you say, well, why is it not 10-year? Because over the 10-year period, the LED will age and there will be a slight shift in color. But 5 years, the fact that in 5 years, I could buy a room full of 50 fixtures and they all would look the same color is pretty amazing. So let's talk about the components. One of the components is this thing called LED. And what LED stands for is light emitting diode. So on the screen, you see a tape strip. The little yellow dots are LEDs. This great big hockey puck thing is an LED array. So underneath this yellow thing would be a bunch of LED chips making up the LED array. And why is it not white? Well, the color is the phosphor coating. Typically, an LED that we use for white light is blue. Well, we don't like blue light. So what we do is we use a phosphor coating in front of the LED, and that converts the blue color to shades of white. So the white determines the color temperature of the static white LED. So, I have a LED array. I have some sort of driver because these LEDs, each one of these LEDs just requires 3 volts DC to make it work. And if I plug that into the line voltage, that's 120, the LED would light up very quickly, and then the magic smoke would come out and you would never light it again. So we use this thing called a driver that converts the AC of the line voltage to the correct voltage for the LED array. So if I was driving one LED, it would be 3 volts. If I was driving, say, 10 that was under this array, this LED might require 30 volts. So you have to match the driver to the LED array. And then all of these two devices then go in some sort of fixture. And the dimmer then controls the LED driver. So here's the anatomy of an LED retrofit bulb. The LED array determines the quality of the light. So it's not interchangeable. So you can't get, oh, I want the super duper version of the screw-in light bulb. It's just whatever version they made. The optics, which is built into the light bulb, determine the beam spread. So they're really not field changeable. There is a driver in the base of these screw-in lights, and that determines the compatibility and the dimming performance. And that's not interchangeable. And typically, the base can either be the Edison, which is the screw-in one you see here, or it can come in different versions. And typically, these lamps come in all sorts of variations, such as Edison, PAR 20, PAR 30, track head, pin base, like the GU24 they use in California. So just remember that when you buy a retrofit bulb, it contains everything apart from the dimming system. So it contains the driver, the optics, and the LED array, and they are non-changeable by anybody in the field. So the performance is the performance. When you specify a fixture, the LED module is often interchangeable. There's often a couple of versions that they can use. The optics are also changeable, so you can get things like different beam spreads, wall wash, things like that. The driver often comes with a variety of drivers, so you can choose, oh, well, I want the 10% dimming version or the 1% dimming version or the 0.1%. I mean, you don't change this in the field, but it is changeable at the manufacturer. And the manufacturer does all the connections between the driver and the LED array. So all the electrical contractor has to do is just run power wiring into the driver and connect the correct dimmer, and then everything should be good. So this is the Um, it keeps asking me for annotation, and every time I do it, it jumps, it stops my control. Light quality. So let's talk about the quality of an LED. You've probably all seen beautiful stuff. You've all probably seen really subpar stuff. Typically um, decorative style things that you would buy in Home Depot and Lowe's is probably on the lower quality end. Stuff you buy through distribution, through dealers, is often much higher quality. So let's talk about CCT. CCT is correlated color temperature. The higher the color temperature, the cooler the light. So for example, sunset and sunrise is about 2000 Kelvin. Think of sitting on the beach watching the sun go down, or where you guys probably on the East Coast, you watch the sun come up. So when it comes up in the morning, it's that beautiful red glow. The whole sky goes red. We think that's warm, so we call that warm white. As the sun goes up in the sky, and we go out in the noonday sun, it can be 6000 Kelvin. It actually gets a higher color temperature when it's overcast, because the clouds, they are white and they reflect a lot of the light back to us as a higher color temperature. So the higher the color temperature, the cooler we call it. The lower the temperature, the warmer we call it. Um, then there's this measure that I keep using called CRI. So if you look at the lady's face, she is illuminated by different light sources. And you can see if I'm in the 50 to 70 CRI, I look like I'm lacking some of the reds. It looks like a more bluish light. And the CRI is low. If I then increase the CRI, I'm now getting some of the skin tones. And then when I move the CRI to a much higher level, I get a better representation. So CRI was a standardized color swatch that they first described, and it was really pastel colors. And you say, well, wait a minute, we don't really use that much pastel colors. Where's the red? Where's the green? Where's the true blues? So the CRI was a really subjective standard. And later on, they added the primary colors and a few other test patches to try and compensate. Typically, most manufacturers still use the CRI as it's called the R1, or the reference 1 through 8. And then they may throw in the R9 number, which is red, and that has a dramatic effect on lighting. So for example, if you look at these three pictures, the original picture has a light source with a 95 CRI, so it represents colors almost the same as the sun or an incandescent. This middle picture has a CRI of 80. So you can see it looks to be lacking some of the reds. It looks a bit washed out. And then on this other example, the CRI is also 80, but why does it look so good? Because what the light manufacturer did is they enhanced the red, which is not given in the CRI value. So it's a little bit problematic, and we'll come back to this picture in a second. So to alleviate this problem, rather than using CRI, the IES developed a new method called TM30, and it's a much more uniform color space. So instead of the 8 samples with the extra few to give you 14, the IES has chose 99 color samples, and this gives you a more uniform representation of color. They also changed what's called the color space to a more uniform one, and the output of this TM30 is three things now. Instead of just CRI, they're going to tell you about saturation or this color vector graphic. And I'll explain how they play. It's a really easy picture once you've seen it. So if we go back to our original, you can see if we take the original, the saturation is actually 100 and we measure at 93. On these two pictures in the middle and the right, they have the exact same CRI. Why do they look so different? Well, the reason they do is the one in the middle has a saturation of 90 and the one on the right has a saturation of 110. And what I can tell by the words here, red enhanced, it means this manufacturer has used the regular LED to create white, but they've also mixed in red to overdrive the reds. And you can see that in the picture. Like if you look at the original, you can see the flower here is sort of red. In this one, it is more red. The reds on the wall are popping a little bit more. In comparison on this one, if you notice, the blues are slightly bluer. That's because they desaturated the red and they shifted more to the blue from the LED. So what does it mean? Well, with the new metric, you get a pretty picture, these two circles. The dark circle in the background is called the reference. That is 100 CRI. So my original light source, you can see, I've slightly, on the original, I'm slightly overdriving in the blue because as I come outside the circle, I am saturating certain colors. As I come inside, I am desaturating. So I'm on the original, I'm slightly desaturating the green, yellow, and I'm slightly increasing the red. On the middle one, it is obvious. I've lowered all the reds, I've lowered all the greens, but I've slightly increased the blues. On the red enhanced, I've overdriven the reds and I've overdriven the greens. That's why it looks almost the same as the original, even though the CRI was low. So what I'm telling you is CRI is not a good measure of the quality of the light. You need to also understand the saturation of that light. So here's a typical example. In this example, the manufacturer says the R9 is 95. That's a very high level of CRI for the red. So it's going to give you true representations like that picture on the right. Please note that this manufacturer offers two versions, an 83 CRI or a 97. So what gives? Well, if I use the 83, because the R9 is at 95, I'm going to have fairly good quality light. But why wouldn't I use the 97 for everything? The reason I wouldn't is it costs more money. It's a more expensive fixture. So the 97 could be used everywhere, but it is common to specify this higher cost LED in important spaces, like when you're showcasing artwork, or you're in the kitchen, or the entertainment areas. And then the other areas just use the 83 CRI with the high R9, and the light will look fine. So let's talk quickly about controlling LEDs. How do I control LEDs? Well, with a fixture, the driver can be specified. The enclosure is often, that's provided by the fixture manufacturer. The lamp module is provided, but I can choose the right driver. With a lamp, the driver is permanent, so I have no choice. I buy the lamp. So how do I control these LEDs? There are 4 questions you've got to ask yourself, and I'm going to cover these 4 questions. So the first question is, what type of LED product am I using, a lamp or a fixture? Well, if I am doing a retrofit lamp, um, it's very difficult to find the information. So, have an exercise. Go to a lighting distributor or even a Home Depot or a Lowe's. Pick a lamp off the shelf and look. Do they give you the CCT? They'll probably say it's a 3,000 or 2,700 Kelvin. Do they give you the CRI? Do they give you the R9? Remember, the R9 can improve a poor CRI to give you a more natural light. Look for the dimming range, not just the words dimmable, but how far does this dim? And then, is it compatible with the certain dimmer? And the takeaway from this is, don't believe what they tell you, because they won't tell you anything. Test it. With a fixture, you do get the CCT, the CRI, and the R9 value. Look at the warranty and the dimming range, because there's often multiple ranges that they offer. And get a list of the compatible dimmers, and testing is not necessarily required. So, where would I use these applications? Well, architectural downlights, I probably want a fixture because selectable trim, internal drivers with the chip. Cove lighting, I want to select the right tape light and an external driver to give me the dimmability. But if I am controlling retrofit decorative access, sconce, table lamps like that, those can only be screw in. So, investigate and test. And track lights tend to be screw or plug-in lights. Again, those are in the same order of the integral LED driver and light engine in the light source. So again, investigate and test. So what's the dimming range and the performance? Well, this graph represents how we see light. So unfortunately, measured light has nothing to do with how we see it. Our eye has a pupil, and as the light dims, our pupil dilates. It lets more light in, and our eye becomes sensitive. So our eye doesn't have a straight line response to measured light. So for example, we reference everything at 100%. If I measure the light at 50%, because of how my pupil responds, my brain perceives that light, instead of dimmed by 50%, I have now only dimmed by 30%. So this gets a lot worse. Dimming for LED is typically standard between 5 and 10%. So if I buy a 10% fixture and I put this on this IES curve, it turns out that my brain, instead of thinking the light is at 10%, to me, it looks like it is at 32%. So that's not very good dimming. If I go to 5%, it looks like I'm at 22%. If I go to a 1% device, it looks like I am at 7%. So you can see really deep dimming is important for certain spaces. So you need to be able to understand what is the dimming range of the product that you're specifying or purchasing. So if you pick a box up of a screw-in LED and it just tells you dimmable, that may not meet your expectations. Now it gets a little bit more complicated with performance. All I've talked about up to now is dimming. Well, there are some LEDs on there that can change the color as you dim. That would be called warm dimming, and they mimic how an incandescent works. There is tunable white, where with the control system, I can change the color temperature at will and change the intensity independently. Why would I want that? Well, the reason I would want that is I might be changing the interior of my property. So, when I first did my installation, I had beige walls. Now I'm going to go for green walls, and all of a sudden the color temperature of the light looks totally wrong. If I had tunable white, I can readjust the lighting. And then at the other extreme end is color changing, where I can now change the shades of white, I can dim, and I can get whatever color I want. There is also another question to ask. What's the minimum or maximum number of lamps or fixtures that be connected to one dimmer? The old dimmers were rated for incandescent light sources, and they have what's called a minimum load of 25 to 40 watts. So if I'm changing my chandelier over my dining room table and it had 3 of the old candelabra, 25-watt incandescent light sources in, I would have had a 75-watt load and my old dimmer would work. I now put in my 3-watt candelabra LEDs. I've now got a total load of only 9 watts. That old dimmer will not work because it's not got the minimum load connected to it. So dimming can be compromised. The other problem that you get is there is a very high inrush current. So these LEDs or a fixture has to convert AC to DC, and they use a device called a rectifier bridge and a capacitor to store the energy, to smooth it out, to give stable DC to the LEDs. That capacitor, when we turn onto it, takes a large current, and it's called inrush. You can mitigate that current by electronics in the fixture or the lamp. Most manufacturers do not do that. So the problem with that is if I take, say, a 600-watt dimmer and I use a bunch of 10-watt LEDs, according to the math, I could put 60 LEDs on the dimmer, but that is not the right solution because of the inrush current. The current that they draw is far excessive the 10-watt rating because of the inrush. So when you purchase a LED rated dimmer, it often has a lower minimum load, so you only need 1 to 2 lamps. But it also has what you would think is a lower rating. But that lower rating takes into account the LED inrush. So on a true LED dimmer, instead of worrying about what the inrush current is, I just take the wattage of the LED. I know the wattage of the dimmer, and it tells me how many LEDs I can actually put on this dimmer. In this case, 15. So the next question is, what type of control does the LED operate? What type of dimmer do I need? The driver and the control must match. And this is where a lot of customers have serious problems because the dimmer they purchase to drive the fixture that they want is incompatible. So there's multiple types. There's 2-wire forward phase. That would be the typical screw-in LED or a 2-wire LED fixture. This is the most common dimmer that's out in the world. There is something called reverse phase, which still uses 2 wires, but that was traditionally used for electronic low voltage transformers. So, in the old days, it was for electronic transformers on track heads. These are traditionally a more expensive dimmer, so they're not as common. And you can see the waveform is the reverse of the previous one. And then there is 0 to 10 volt dimming. This is the industry standard right now. So it requires a dimmer that can give a switched hot to turn the fixture on and off. And then I have to run a pair of conductors, 0 to 10, to the fixture to tell it what dimming level to go to. And unfortunately, there are 2 standards in the United States. There is an IEC standard called IEC 60928 Annex E2, which specifies that the driver, the thing inside the system, shall supply the current to create the 0 to 10 and the dimmer shall sink that current. There is another standard called the ANSI standard, which comes from the theatrical world that says, no, wait a minute. The dimmer shall source the current and the LED shall sink the current. Obviously, if you have the wrong dimmer with the wrong driver, the two are incompatible. The other issue is there is not a specification that tells me what voltage the light is supposed to go to other than at 1 volt or 10 volt. The specification reads at 1 volt or below, the fixture goes to minimum. At 10 volts or above, the fixture 9 volts or above, the fixture goes to full. What happens at 5 volts? It's not specified. So if I am using a control and multiple manufacturers' fixtures and I dim them, they could potentially all be at the different light levels. And then there's digital. I know I'm running a little bit late, but I've just got 2 more slides to go. There is digital control. This came out of Europe. And you may have heard of DALI or ecosystem in the United States. Basically, each fixture gets a pair of conductors and it gets constant power. So you don't switch the power comes from a breaker. But what you do get is every fixture is wired together, and through software, you zone the installation. Whereas if I go back to 0 to 10, everything that's connected to the 0 to 10 volt lines all dim together as the same zone. In the digital world, I can say I want this fixture and this fixture to be zone 1, this fixture to be zone 2, this and this to be zone 3. I know this is silly and doesn't make sense. These two with this one over here, zone 4, and it's all done through programming. Later on, when I want to make a change, I just do it through software. So it's a much more flexible system for controllability. And then there is DMX. This is more common in the commercial world. The wiring is somewhat complicated. It's a 3-conductor wire, needs to be daisy chained, needs to be terminated, but it is a high-speed communication and it allows for very dramatic color effects. So you typically see it on theatrical style events. So that's really my LED presentation. I mean, it's a lot of material that we presented, but I'd like to now stop sharing my screen, turn it back to Jeff, and see if you have any questions.
Okay, thank you very much, Doctor. So please use the chat window or unmute yourself if you want to join in the conversation. I've got a couple of starter questions for you here. One thing is clear is you've just explained the reason why a lighting designer is probably a good choice to engage on any significant project, because there's a lot to know here, and I assume that a good
Yes.
lighting designer would know this, right?
Yes, that absolutely is. They will choose the correct color temperature, the correct CRI for the application. They'll understand the performance of the fixture. However, they need to. The reason I like presenting this to architects and lighting designers is they need to be aware of their decision when they are choosing a fixture for the controllability aspect of it. For example, if they choose phase control, they typically don't dim as deep as, say, 0 to 10 or digital control. If they chose digital control, they often have less of the installation performance drawbacks of what 0 to 10 would be. So it's a good idea. They are going to choose the correct fixture for the lighting, but they have to also, at the back of their mind, be aware of their choice of fixture on the control of that fixture.
Right, absolutely. Um, where would one start for that? If you want to find a lighting designer, is there a a starting point for that in a given region?
Typically if you have hired an architect for a design, they will either have their in-house lighting designer or they will have a lighting designer on retainer who they will pass their lighting designs to. So if you're going through that approach, that's already built in, and there will be someone, professional doing that. If you're a homeowner and you're trying to do it yourself, that's where you really need to work with your local rep because they have relationships with the specification community and they can put you in touch with an appropriate lighting designer that will meet your needs. I mean, it's
So
very difficult to do on your own.
that's my experience as well, and we do have a lighting designer that we work with, and we've met a number along the way. It seems like a lot of people in the old school would just go to their electrician for the fixtures, and what we found is the electricians typically don't understand the control aspect of it or any of the stuff that you produce
Yes.
today. So that would be something I'd say you'd have a very special electrician that would know all this in addition to doing what their core job is.
Yeah, I
Um,
mean, Jeff, if I can just touch on that point, that's an amazing point that you brought up. Um, the electrician is going to put in whatever they can put in that gives them the most profitability. So they often go to the owner and say, hey, your lighting designer has specified this fixture, but if I use this other one that's almost the same, I can save you a lot of money. Be very cautious of that because the lighting designer has chose that fixture for a reason. And I teach other classes where I teach people like Jeff's firm, controllability. And this is why I recommend that the dealer drive the fixture package. You know what is right. You know what is the highest performance, and you are not trying to cut corners. You're trying to meet what the customer wants. If the electrician comes to the homeowner with something that's not what is specified, you need to make sure that everything on that specification, the CRI, the R9 value, the warranty, the dimmability, they're all there, and they quite often are not.
so that brings me to my next question. We spend a great deal of time tuning projectors and televisions for color accuracy.
Yes.
And we have specific tools that do that put up, technical terms here, Rec 709, a Rec 2020 color space, a SMPTE color space,
Yep.
and with a generator. And then we have a thing that we either attach to the screen or we measure the reflected light off of a projected screen, and it gives us, how well does the input match the output, and we spend hours making them line up, right?
Yes. Yes.
Um, is that possible with
Yes.
LED lighting?
It is possible. So it's only possible with dynamic LED lighting. So if I am using a static light source, and what I mean by static is it says on the spec sheet it's a 3000 or whatever Kelvin, and it dims to 0.1%. That is static. You are not going to change the color that's coming out of that fixture. However, if you use a tunable white fixture, those tunable white fixtures allow you to independently adjust intensity and color temperature. Or if you use a full spectrum fixture, you are able, by the way, we finished the presentation, right? So I'm going to,
Right.
so an example might be a full spectrum lighting is a light source that Lutron provides called Ketra. So in Ketra, I can provide 16.7 million colors, shades of white from 1,400 to 10,000 Kelvin, and I can dim to 0.1%. So what a lighting designer would do, they would come into the space, they would use a photometer, and they would actually measure the shade of white that's in the space. Now, the shade of white may be different. So say I painted the walls beige. Well, beige has some reds in it. So the way light works is what we see or perceive is the reflection. So I am shining my light on the beige wall and it is reflecting back, but it's absorbing some of the blues and things like that. To get a certain color in that space on the work surface, I might have to drive the blue a little bit higher. So the lighting designer may choose to tune the blue up. Well, unless you have a dynamic light source, you cannot do that. So to answer, a really short answer on your thing, Jeff, is yes, we cannot do it. The homeowner can't do it. I mean, they can experiment, but a lighting designer would have a tool to allow them to tune it exactly where they want, if that was the requirement.
I imagine if I was lighting up a museum or something, I would go every couple of years and retune it,
Yes.
right? Okay.
Yes.
Wow.
Or,
I
or
had no idea that existed.
when you change the exhibit, like the lighting for one exhibit may not be correct for the next. So if you're using dynamic lighting, you can come in and you can adjust it, whereas static, you cannot.
Interesting. So all of this translates back to televisions and projectors as well, because if they're changing over time, I mean, I guess that's what a cheap LED TV from Costco compares to a high-end Sony A9 or A10 then, right?
You
That's what you're paying
absolutely got
for.
it. That's what you pay for.
Yeah. Yeah. Oh, that's interesting. I'd never heard of the McAdam ellipse color consistency before today. So I did I did take that away. I think I had a gist that something like that existed, but I've never seen it. That's fascinating to me. We do test a lot of fixtures here because we've noticed the dimming performance. You never really know what you're getting, and like you say, is the package doesn't tell you anything, and the only real way to test it is to literally hook it up to a
Yep.
to a dimmer and see what happens. I also noticed when we did do the 0 to 10 volt system that in the Lutron case, they send a hard off because it doesn't dim to zero. It dims to whatever it dims, and then you kill the power to make it go off.
Yep. That's 0 to 10. It requires a
Yeah,
switched heart and a 0 to 10. So
right.
it overburdens the control system. So think about it. If I'm in a kitchen and I've got 4 zones of lighting, I essentially have to have 4 0 to 10 volt controls. Whereas if I do it digitally, it's just the same pair of wires because I can digitally address them with a Lutron system.
Right, right. We encountered a LED system for outdoor landscape lighting that claimed it's a two-wire bus like you're describing, so you run regular 2 low voltage wires to every lighting fixture. But we all know that the one at the very end of the chain is receiving a lower voltage than the one at the beginning of the chain because we have
Yes.
loss per foot, and then
Yes.
there's a load. If you have 10 LEDs on there, then so forth. Naturally. So the system would send a signal down to a smart LED that would all send back reference levels, and it would auto adjust so that 5 years down the road, the first and the 10th LED would all look at the same brightness, and you know
That's if
one
it
year
was,
down the road it would
yes.
be different, but they would
It,
all
it,
be the same.
yes. If it was digital, they would all be the same. If it was 0 to 10, they're all different just because of what
They're
you
all
just
different.
described. Yep. And I
It,
mean, I have a smart ALEC reply. So what you're talking about is voltage loss along the wire. So the only thing I know that has essentially zero losses is either you take it to 0 Kelvin, which is ridiculous, or just use gold wire.
Yeah, solid gold will get you there.
Yeah.
Well, so I guess where I was coming from is these fixtures, their selling point was that they're intelligent enough to auto balance their light level. Now outside, you're not dealing with 16.2 million colors. You maybe there's only just one or two that you're using. The question is there any sort of auto leveling that would keep it consistent over
Yes.
time?
Yes. So Lutron, we have a family called Ketra. Inside the Ketra lamp is a red, a green, a blue, and a white LED, and that's how we get the colors. We can mix those four LEDs to get any of 16.7 million colors. But there are receiver diodes also built into the emitter to the LED array of a Ketra light source, and 360 times a second they measure the light output, the color that's produced by that lamp, and recalibrate the lamp 360 times a second to make it match the reference lamp that they were calibrated on at the factory. So over the 10-year life of a Ketra lamp, it will always be at the exact color you tell it to be. So if you had a room of 1,000 Ketra lights and you told them all to go to a certain shade of purple, they would all be within one macadam ellipse, that shade of purple.
Now that is fascinating to me because that means you've got this dynamic feedback loop built in,
We
keeps
do.
everything perfect. That's amazing. Well, it's certainly the Philips Hue bulb for $2 at Home Depot doesn't have that level of sophistication.
No,
So
no,
so there's
that's
a
the
lot going
difference.
on here. It's the color accuracy over time, the dimming performance, the color accuracy. I mean, there's like so many different things to consider here, and now I can see why those fixtures are so expensive compared to something that someone would come up and say, yeah, it's almost the same. It's got the same numbers on it, but
Right.
it's not the same
It's
at all.
not. Yeah,
Wow.
that's the. I mean, you summed it up with things that people understand. You go and buy the Walmart TV, or you buy the big Sony, whatever version it is, and you pay whatever it is, 5 times the price. That's the reason.
Yeah. Yeah, that's interesting. And then keeping that reason consistent over a longer period of time is really what it's about. Well, that's great. Hey, I noticed Deb G from Lutron logged on. Wanted to say hello, Deb, and invite you to participate if you've got any questions. Looks like we're right at 12 o'clock here, so
Hey
maybe
all.
we ran out of time. But I
Hey,
wanted to
Deb.
say hello to you.
Yeah, thank you very
Hi.
much, Dr. Rowbottom. Thank you, BTA, for having us. And I thought that CEU is really fascinating. I'm always learning more every time I listen to Dr. Rowbottom. And if you have any questions, certainly Jeff, Marcia, anybody from the BTA team will be able to help. I am Deb Giratana. I'm the rep for Lutron, and also happy to connect you to Jeff or Dr. Rowbottom. Thank you so much for your time and attention.
Oh, thanks, Deb. All right, so with that, I guess we'll wrap up today's presentation. Thank you, everybody, for staying on, and we'll see you next week. Thanks again, Doctor.